Great, thanks very much, Raquel. So as discussed, what we'll be looking at today is around pathways to reduce the carbon footprint in meat chicken farming. But prior to really delving into that, we'll also look at what baseline emissions were determined for meat chicken production in the year FY20. And we disaggregated and reported impacts for both conventional and free range production. And the way we went about this project with the support of and funding from AgriFuture's Chicken Meat Program was to survey industry, and we ended up collecting data for approximately 50% of the birds processed in Australia in FY20. So an acknowledgement and thanks really does need to go out to industry, and I'm sure there are many people online in this webinar who either directly or indirectly contributed to this project. So as sort of a precursor and sort of a why we're here and why we're talking about this today, it's quite important to understand the impetus, whether at the individual level or a business level or across the economy, as to why acting on carbon or understanding emission baselines is really important. And probably the first driver, and in many respects one of the most relevant for the meat chicken industry, is really around drivers from customers. Notably, the big two retailers in Australia have either set targets around their own emissions or are also setting targets around their supply chain emissions. Another driver is from the business sector and sort of non-governmental organisations. Science-based targets initiatives is a key one there, which really aims to sort of promote and encourage baselining and reporting of emissions across all sectors of the economy. Thirdly, finance is increasingly relevant in this space. Banks are in the process of either benchmarking the emission profile of their borrowers and setting targets around that improvement, but investors are also sort of increasingly interested in this space. And a key call out there is actually the task force around climate-related financial disclosure, which is sort of acknowledging that for many publicly listed companies, some of their profits do actually depend on sort of what's going on elsewhere in the environment. And that, significant variability in that space could actually have a detrimental effect on their earnings. And fourthly, regulation is sort of gaining a lot of traction, particularly with the change in federal government of late. They've introduced a new target, I'm sure you're aware, to reduce economy-wide emissions by 43% by 2030. And that's from a 2005 baseline, which is a more aggressive target than we had under the previous federal government. But the target of 82% renewable energy contribution to the national energy market by 2030 is something that should help facilitate some of that 43% reduction. And alongside that, state governments have set targets and are sort of on an ongoing basis updating those targets for the contribution of renewable energy sources to the state electricity supply. And that should have a passive benefit, again, for the rest of the economy, including meat chicken production, simply through the decarbonisation of the energy supply, specifically electricity. There are a couple of future changes that we could expect. Probably a main call out is around the safeguard mechanism, which currently agriculture is exempt from that. However, there is a process that's been in progress over the past few months, which is around a review of that safeguarding mechanism. And there has been a public consultation process around what changes might be needed. In that, agriculture still isn't necessarily a call out. However, a lot of the submissions to that review, including I think from the Climate Council of Australia, have said that probably some other mechanism is needed, even if agriculture isn't to be included under the safeguard mechanism. But what that mechanism really does and is designed to do is to facilitate ongoing reduction in emissions over time for large polluting businesses. So that those are businesses which produce 100,000 tonnes of CO2 equivalent per year of scope 1 emissions only. And I'll sort of delve into what scope 1, 2 and 3 emissions mean, particularly in relation to the meat chicken industry, as we go on in this webinar. So under the NGES scheme, which is in place at the moment, agricultural emissions are not currently reported. Emissions from processing, however, are. There's also potential there for amendment and for reduction in the reporting limit thresholds. What that will be, when they'll come in, who will be included, however, is uncertain at this stage. And, it probably does depend on how the economy is tracking against the national targets. So, spoke a bit earlier about the non-regulatory GHG context, and customer targets are the key call out there. And around scope 3 emissions, Woolworths is the only major retailer at this point in time to have a target around their supply chain emissions. And their aim is to reduce those supply chain emissions by 19% from a 2015 baseline. So anything that's sold on the Woolworths shelf, be it beef, eggs, chicken meat, is in some way either implicitly or explicitly subject to that 19% reduction target. Then we also have a number of targets being developed by major lenders. CBA and NAB are two call-outs here. And really what they're aiming to do is to benchmark the emissions of their borrowers and then to set targets for reducing those emissions over time. Sustainability-linked loans, which, might offer a better interest rate against borrowing for companies which have some sort of strategy to reduce their emissions, are in their inception. But it is quite likely that they might become sort of more relevant and more widely available over the next few years. So that then leads into this project, which was really set up by AgriFuture's Chicken Meat Program and the federal government, recognising that we don't actually have or didn't have a comprehensive baseline for emissions, but also fresh water consumption or fossil energy or land occupation for Australian chicken meat production. Work has been done previously, notably by Steve Wiedemann and Eugene McGahan, who will probably chip in a bit later on this webinar. However, that really only covered a subsection of industry, and sort of there have been a number of changes since that time, so that an updated baseline was needed. And the way that baseline is determined is via life cycle assessment. And the purpose of that assessment is to determine or quantify the environmental impacts of a product across its entire life cycle. So that really enables us to understand the contribution of various stages of that life cycle to the overall environmental footprint of that product, and to understand how those impacts might change over time, because life cycle assessment is really designed as an iterative process. So we assess the inputs and outputs relative to the products produced. So in terms of chicken meat, we cover everything in the supply chain. So it might be right through to the abattoir gate, including grow-up farm, breeding and hatchery, feed milling, feed production, but also the extraction of purchased inputs further up the supply chain. And life cycle assessment allows us to include and assess impacts across a variety of indicators. And I've sort of called out the ones here which we directly assessed as part of this study. So it wasn't just climate change or greenhouse gas emissions. We also looked at land occupation, fresh water consumption, water stress and water scarcity, and fossil energy use. And cycle assessment isn't some just arbitrary thing that anyone can sort of claim to have done. There are very rigorous and very widely known, internationally recognised methodologies set out by ISO. So there's one around life cycle assessment. And that really sets up how we perform this is to determine the goal and scope. We then collect inventory data and analyse it. And then we conduct our impact assessment by running it through models. And finally, that really comes down to interpretation. We might conduct sensitivity analysis on key parameters to understand and really explain clearly what drives the environmental footprint of the products that we're talking about. And as I mentioned, this analysis was particularly strong in terms of inventory data. It's certainly the largest that's been conducted in this country, in the chicken meat industry, collecting around 50% of birds processed in FY20, and we covered production in all 6 states. Across other indicators, there are still set methodologies around water footprinting and specifically the carbon footprinting of products. But in terms of impacts for the chicken meat industry in 2020, what we've got here is the water consumption per kilo of chicken meat product. So that's at the abattoir gate, what's gone into, what water has been consumed to produce that product. And you'll see that feed production, which is this top green bar on each graph, accounts for around 88 to 89% of the freshwater production, freshwater consumption rather. So that is a key call out, and it'll probably become clearer as we move through, if you're not already aware, that a large proportion of environmental impacts for chicken meat production are actually associated with upstream feed production, particularly, the cropping process rather than feed milling itself. And, proportionately, although we've got 179 to 190 litres per kilo of chicken meat as the water footprint, the actual contribution from meat processing, grow out and breeding is relatively low, which really does highlight the efficiencies which are already in place across those phases of the life cycle. Now, fossil energy use, what we're looking at here is around 18 to 19 megajoules of fossil energy per kilo of chicken meat. Feed production is still the major source of fossil energy use across the life cycle of chicken meat production. Housing represents about 20%, meat processing around 13%, and application of renewable energy or reducing fossil energy use through improved efficiencies at any of those stages does contribute to a lower fossil energy footprint. So getting into the focus of this webinar a little bit more around emission reduction pathways, there are an archetypal series of steps that we use to really walk through that process. And the first is understanding emissions. So we know where emissions arise, what our opportunities to reduce are. And the second part is around what's the baseline? Where are we setting targets from, or at what point are we saying, okay, the federal government has a target based on 2005 levels as the baseline for an individual grower or individual company. Is that where they'd like to set their targets from, or are they working from 2020 or 2022, for example? Because that's key to setting those benchmarks and actually identifying what achievable targets can be set. And then the third stage is really around the implementation of those strategies to reduce emissions. And the fourth stage is around storing carbon, or if you can't store carbon, as in inset against your own carbon, then purchasing offsets to offset the remaining emissions to get you to zero or carbon is what we're after there. And finally, the fifth, monitoring progress. So what might happen in this stage 5 is that we realise that or we're exceeding our targets. So potentially we can actually go back and strategies for implementation. So we'll start stepping through this pathway in terms of understanding emissions. And what we've got here is an operational boundary, or what we call an operational boundary for a typical grow-out farm. And they have scope 1 emissions, and those emissions are really associated with farm operations, particularly emissions from manure, but also emissions from diesel or gas use. There are also scope 2 emissions, and scope 2 is refers to emissions from grid supplied electricity. So scope 2 does change wherever we are in the supply chain. A grow-out farm or a meat processing company, scope 2 emissions for them will always be the emissions associated with their grid electricity consumption. But we also have something called scope 3 emissions, which on one side we refer to as upstream, and in this case that's pre-farm emissions. So they might be associated with the breeding and hatchery processes which produce the birds which come to the farm, but that can also extend right back into emissions from the production of purchased inputs. Feed commodities is the big one there. However, if you use diesel at the farm level, that also has a scope 3 emission intensity, which is really associated with the emissions which have gone into extracting and refining that particular product. And then on the other side, we have downstream or post-farm, in this case, scope 3 emissions. And that's really everything after the farm gate. So that might be meat processing, transport emissions, any value adding done to the chicken meat that was produced from birds grown on the farm, distribution of the product, and the emissions associated with, supermarket and retail operations. But the classification of what is scope 1, 2, and 3 does vary depending on where we are in the supply chain. So if we look briefly at a vertically integrated processing company, their scope 1 emissions are really around abattoir or meat processing operations. So any energy use such as LPG, for example, that they might use there, or diesel, but also wastewater, emissions from wastewater and effluent at that stage. In the event that they operate their own hatchery and breeding facilities, feed mills, are in charge of their own transport, that also falls under scope 1 emissions. The scope 2 emissions, as mentioned, are still grid supplied electricity emissions for the electricity that they consume and pay for at the sites that they operate. Their upstream or scope 3 emissions are largely, if we assume they don't own any farms, contract grow-out farming, but also the emissions from the production of purchased inputs. And again, feed commodity production is the call out there. And then downstream for them might be transport emissions if they don't operate the transport all the way through to the retail shelf. Any post-processing, if that doesn't fall within their business remit, distribution, and emissions at the retail shelf. So the operational boundary was key because in this project, what we looked at were the emission intensity or the environmental impacts associated with chicken meat from cradle to abattoir gate. So we didn't include retail operations in this assessment, but we included all impacts right back through to breeding and hatchery, the production of feed commodities, and the extraction of the raw materials which goes into those processes. So we've separated our impacts, or in terms in here, greenhouse gas emissions by supply chain stage. So we have something that we've rather broadly grouped as breeding and hatchery operations, grow-out operations, meat processing, feed commodity production, and this rather ambiguous image over here is soybean meal production in South America. So breeding and hatchery contributed around 4 to 8% of the emissions per kilo of chicken meat products. Grow out could range between 9 to 17% of the emission profile. Meat processing, which was really driven by fossil energy use there, represented a similar proportion of emissions, around 8 to 15%. And then feed production could account for anywhere between a third to 2/3 of the emission intensity of chicken meat production. And the reason for that range in the contribution to the carbon footprint of chicken meat is really to do with imported soybean meal, which in the Australian import market, there's almost complete market dominance from the South American region. And so the issue with imported soybean meal as it stands is that soy is really grown on cropland, which has been converted from either pasture or grassland or forests to cropland. So there is a high degree of soil carbon loss associated with that product. And that was one of the key findings in this project compared with the study done a decade ago, when a larger proportion of soy in the import market was actually from the US. Now, that soy was grown on land which has, been cropped for decades, generally. So there wasn't that soil carbon loss associated with that product, and it was a lower emission intensity product compared with what's available today. So if you didn't have any imported soybean meal in your diet or imported soy from South America, then, the grow out, for example, the contribution of that to the carbon footprint would be around 17%, meat processing around 15%. However, if there was a high level of soy in the diet, that could represent nearly half the carbon footprint of meat chicken production. And so we'll get into strategies a little later on, which sort of delve into how to address the emissions from that soybean meal. But one thing we do have a bit of a question mark over is how much or what can the industry do to sequester carbon against, their emissions to offset those emissions. But baseline results for both conventional and free range for 2020 are here. And you'll see that conventional is ever so slightly lower in terms of carbon footprint than free range. We're talking about 2.1 to 2.2 kilos of CO2 equivalent per kilo of chicken meat. We did run uncertainty and Monte Carlo analysis on that, and that does confirm that it is statistically significantly lower. And probably one of the reasons around that is really to do with efficiency, that we did see slightly better FCRs in conventional production, but they also just, that sort of flows through to all other stages in this carbon footprint. So if you've got a better FCR, they do produce slightly less manure, and there are fewer inputs associated with producing 1 kilo of chicken meat. But as you can see, based on what we saw on the previous slide, breeding and hatchery processes are, very small contributions to the carbon footprint. Meat processing and grow out are roughly equal. Feed production is significant, but when we add in the weighted average diets for chicken meat production and the reported soybean meal inclusion rates, we get something called land use and direct land use change emissions. And these are quite significant, adding in something in the order of around 1.7 to 1.8 kilos of carbon dioxide equivalent to the carbon footprint of chicken meat production. So taking it from around the 2 kilo mark up pushing the 4 kilo mark. But it's not all doom and gloom. I'm sure everyone's aware, eggs and chicken meat production or poultry production in general is a very efficient, highly efficient production system. And so that really follows through into the emission intensity, that the emission intensity of chicken meat is one of the lowest amongst the animal proteins. However, that isn't really significant difference between egg and chicken meat production. And land use and direct land use change impacts, which are driven by that imported soybean meal from South America, affect both eggs, chicken meat, and pork. And they're not included in this graph here. However, even if they were, we would still see eggs, chicken meat, and pork as being significantly lower than red meat production. And when we talk about vegetables or grains or plant-based proteins, their emission intensity is, again, slightly lower than eggs and chicken meat production. So moving on to stage 3 and 4 of that low emission or low carbon pathway around reducing emissions and then offsetting residual emissions, we'll start talking about the sort of secondary focus of this project, which was around strategies for low carbon or carbon neutral chicken meat production. But before we delve into that, there is quite an important distinction to make, and it's about two terms which can often be confused, but they are key to disaggregate across the supply chain and across the various stages of chicken meat production in terms of who's responsible for what source of emissions. So net zero really refers to business emissions. And those are your scope 1 and 2 emissions. And we call them business emissions because they're the ones that typically an entity has the most direct control over it. So they're the things that might, appear or correspond to things which you are invoiced for. So LPG use, diesel, any litter that you might purchase. Or for a processor, that might extend again into their energy use, but also into packaging that they use to send their products out. Part of the challenge is that a lot of targets over the past few years have been established around net zero emissions, so achieving net zero, and our economy-wide targets by the federal government is a good example there. However, as other sort of nations and entities around the world, I think, are cottoning on to the fact that some targets are not ambitious enough or are too ambitious, it's leading to a bit of a rethink around how these targets are set and what the scope of them should be. And so the ISO net zero guidelines, which have been released in the past few months, really say that scope 1, 2, and 3 emission sources should be included in net zero targets. That's a should, not a must. But life cycle assessment, and in particular carbon footprinting, if you want to make a claim of carbon neutral under the federal government standard, which is climate active, for example, that has to include impacts across the full supply chain. So scope 1, 2, and 3 emissions, wherever you fall within that supply chain, have to be included. So if we were talking about a carbon neutral chook you can buy in the supermarket, that would have to include the emissions right back through the supply chain, including those emissions associated with land use and direct land use change from the soy. They would have to be either reduced or offset. So we developed some business as usual sort of case studies or a business as usual scenario for the industry, really just to highlight out to 2035 where the industry would be then versus today in terms of total emissions. And so we did make some assumptions with input from key stakeholders. One was that we assume that the industry will continue to grow at 2% per year. And the other was that annual improvement in FCR will continue as a result of genetic gains, advances in feed, composition, etc. And you'll see that, unfortunately, the total emissions do continue to increase. We look at this red line up the top. However, scope 1 and 2 emissions do decrease slightly, and that's really to do with the decarbonisation of electricity grids, which should have, even if the industry does nothing, some sort of passive benefit for the industry in regards to their scope 1 and 2 emissions. However, you'll see that scope 3 emissions, which are orange, so they're largely associated with feed production, and scope 3 land use and direct land use change emissions, so the emissions associated with imported soybean meal, continue to increase if there's no change in current or business as usual production methods. However, I guess the good thing and the call out from here is that based on these scenarios, total emissions will grow at a slower rate than the industry is set to expand. So that really again highlights the fact that this gap is attributable to the improvements in FCR and improvements elsewhere in the economy in terms of emissions, notably the electricity grids. So we did model a variety of mitigation scenarios, and we screened those across a number of criteria based on sort of the emission source targeted, what with various adoption rates and efficacies we could reduce total industry emissions by. We considered whether they were economically viable at this point in time, whether they're actually available for implementation on a broad scale, so beyond just, trial stage, whether there was research and development required to make those technologies or strategies applicable to chicken meat production. And based on those sort of key criteria, we developed a hierarchy which was around their priority for implementation. And so we broke them down into all our strategies or scenarios down into some broad groups. And the first was really around diet and performance, noting that that is a significant contributor to the carbon footprint. So we looked at things like FCR improvement, reducing the emission intensity of feed, particularly imported soybean meal, so through certified soy or alternative proteins, low emission feed ingredients, so reductions in the carbon footprint of Australian feed grains, insect meal and reduced dietary protein. We then looked at energy and sort of that ranged from already established, implemented, proven technologies like solar and just straight energy efficiency to sort of the emerging or more novel, so green power, anaerobic digestion, combustion, gasification, and pyrolysis, so waste to energy strategies, which have, again, that benefit potentially of finding a use for waste or byproducts from the industry. However, those were really screened out either due to just not being proven or available in the Australian context and for the Australian egg industry, and for just, the sheer capital requirements associated with those technologies. We then looked at some manure management strategies, such as covering stockpiles and nutrient recovery. However, due to the fact that that just had very limited emission reduction potential or such high capital requirements, and again, still being very much in the sort of blue sky stage for application, those strategies don't seem particularly viable at this time. And then around soil carbon sequestration and storage, there are some modest emission reduction opportunities there around soil carbon on ranges and application of manure and vegetation on farms. However, they really do need to be evaluated on a case-by-case basis. So just quickly on as an example of how we went about this screening assessment a bit more clearly, using the example of solar at grow-out farms. We looked at the emission source targeted, the contribution of that to the industry as a whole profile, because this was really about developing and directing research and funding into emission reduction strategies, the technical mitigation potential and viability of the technology, its efficacy, estimated industry adoption, what that followed through to in terms of total industry emissions, its economic viability, any co-benefits, its availability, compatibility with other mitigation strategies, whether R&D was required, and any other considerations which needed to be made before directing research and investment into this strategy. So here's our case study emission reduction strategy for a vertically integrated processing company, which does about 25 million birds per year. This is just a model processor. I think we based it in New South Wales, as that has a reasonably mid-range emission intensity grid. But we also assumed no growth in production, which is, again, conservative and probably not necessarily in alignment with what every business is aiming to achieve. However, a large part of strategies and pathways like this is that they are iterative and need to be developed based on performance and business objectives. So our first strategy was around reducing the emissions from feed production, particularly imported soy. So here we managed to offset around 90% of imported soy from South America in the diet, whether that was through substitution with alternative proteins or just sourcing soy from alternative production regions such as the US. And so then we looked at the application of solar on grow-out farms and then energy efficiency at the milk processing plant. And so what this over the course of this pathway was around a 47% reduction in emissions, total emissions, by 2035 from this BAU or baseline scenario. However, that did mean that then we needed to a model processor would need to purchase this volume of carbon offsets or generate offsets themselves in order to reach carbon neutrality. So just quickly before I wrap up, some summary of some opportunities and challenges to the industry. Firstly, this is a production system and an industry with really strong environmental credentials compared with other animal proteins, both in Australia, but also chicken meat production overseas. And supply chain emissions can be reduced by nearly half via technology adoption, management changes, and that passive decarbonisation of the energy grid. The key challenges are really around the access to low emission or carbon neutral grain, alternative sourcing for imported soybean meal or alternative proteins. And if we can't really achieve that, then acceptance of the need of large volumes of offsets to be purchased in order to achieve carbon neutral chicken meat. And so, yeah, that reliance on imported soy as the staple protein for meat chicken production is a significant challenge, particularly in light of the fact that the industry is facing rising costs of production around energy and fuel and feed inputs. So key takeaways, decarbonisation is happening, but a plan is needed for every farm, every industry and every business because it will only get us so far. Scope 3 emissions, particularly for intensive animal production industries such as the chicken meat industry, are a major challenge, and they probably do require a rethink around feed production and procurement. However, an absence of pathways for the grain sector, particularly in Australia at the moment, means that estimating what reductions might be possible is particularly challenging. And sort of the elephant in the room, but the obvious conclusion is that emission reduction, whether it's net zero or carbon neutral, is going to have a significant cost implication. So opportunities to engage stakeholders across the economy as to how those costs might be shared or what trade-offs might be, trade-offs or support might be possible is going to be key to achieving changes in sustainability. But the key point and a great, leverage point is that chicken meat is Australia's most consumed animal protein, and it is one of the lowest footprint in terms of carbon, water, energy, animal proteins. So that's a really strong strategic advantage for the industry. So yes, thanks for the opportunity to present today. I think I've gone a little bit over time, so I'll stop talking now and let, I think, Michelle field some questions.
Thank you, Fran. That was a great presentation, and it's really given us a great insight into what the work that you've done and where the chicken meat industry currently stands in regards to emissions. So thank you so much for that. We do have some questions, and I do actually want to welcome Eugene to the webinar as well now, because Eugene has been involved in this for over a long period of time. And I'm sure he's got some great knowledge and insights into particularly, pathways and how emissions can be reduced. I will start to filter through some of these questions. So thank you everyone for listening and having some great questions. The first one was just explaining scope 1 to 3, but I think that you pretty much covered that already in your presentation. Another one was, why was organic chicken production not included in the study?
Yeah, good question. So we didn't include it in this study. However, it was included in the 2010 study, which, Eugene was one of the main drivers on, so I'm sure he can comment on the differences between organic and conventional production.
We did look at it. I think, we also looked at it for eggs, but it would, probably because it's a small proportion of the industry. I'm not sure why it didn't go in there again. But if you think about organic production and thinking about, what Fran's talked about there, is that you're getting a lot of these, a big proportion of emissions are coming from your feed, so your feed production. So, given that organic production has a much higher feed conversion ratio, that you are going to see a significant difference with organic feed production, basically because you're not using those synthetic, manufactured amino acids and stuff in the diet. So essentially you've got to feed them more grains and stuff. So you would see a significant difference with organic production if it was included in there, but it wasn't included in this study.
Thanks, Eugene and Fran. I have a question in regards to anaerobic digestion. Do you think it would be a good pathway to reduce emissions in farming and use biogas as an alternative fuel, or even as a replacement to LPG?
I probably take that one, Fran. If you look at that presentation there, so the industry we're talking about, so chicken meat production here, so very low emissions from manure now, and that's essentially because the manure is handled in a aerobic process, or hopefully you don't have that much water in your shed that it's gone anaerobic. So essentially what that means is you're not generating any methane. So the business as usual case for chicken meat production in Australia is litter, that's the norm. Litter floors, very low methane emission factors coming off, and in fact even fairly low manure emissions overall. There are some nitrous oxide emissions, which we didn't get into that discussion of different greenhouse gas emissions, but so methane's got a fairly high multiplier, 28 I think it is at the moment, and I think it's probably going to get revised up to that into the 30s or something. And it is quite an interesting topic, because you might have seen in the news lately there's discussions around setting targets on it. So the difference, I suppose, with chicken meat and say the pig industry, where quite a bit of methane capture and anaerobic digestion's been developed, is that they represent over their, a conventional piggery, their manure emissions represent over 50% of their total emissions. So they get a big bang for their buck, basically capturing that methane. For the meat chicken industry, trying to get rid of that little bit of methane doesn't give you a lower carbon, won't lower your carbon footprint much. And in fact, there's a few little intricacies in it and stuff that if you actually take a product that's not generating methane, you digest it, so you're making methane, you actually have to account for a leakage thing in your digester when you've got it as well. So you could actually be increasing your emissions. Yes, you get an offset because you're making energy. So the reason you'd want to be doing it would be purely from an economics point of view, from an energy production viewpoint. And that's either, generating energy and offsetting your heat, offsetting your LPG or your natural gas, or putting in a generator and offsetting electricity, or CHP unit offsetting both. So, yeah, it is an option. And there are a few other little problems with the poultry, is it can generate a lot of ammonia. So the technology costs you a little bit more than, say, the pig industry because of the ammonia inhibition problems you get with anaerobic digestion. But yeah, it certainly can happen. And they're working on, there's a biomethane thing being added to the animal effluent method at the moment, and I think they're looking at including poultry in it besides the dairy and pigs that are in it. So yeah, that's probably the main reasons around it. That explains it from the difference between an energy point of view and a reducing your carbon point of view.
Thanks, Eugene. That gave a lot of information, so thank you very much for that. Just let me look. This is an easy one, is where can we access this report?
So we've just had a journal paper published online, which hopefully you might share with your recording, Rochelle, in the CSIRO journal, Animal Production Science. There is also a report around specifically on the emission reduction strategies and pathways, which I think AgriFuture should hopefully release in the next few weeks or early next year.
Thanks for that, Fran. And yeah, I'm more than happy to share the link to that report that that paper that has been published just recently too. So I will definitely send that out with the link to the recording for everybody so they have a copy of it. Okay, we've got some great questions coming through. Thank you, everyone. The input ranges to calculating the LCA are very broad, yet the output has no range. Why does this study not represent the LCA data as a range?
Sure. Yeah, so that's a good question. And the paper that Rochelle will share a link to has the ranges for all the input parameters for all the data we collected. And it does also give the standard deviation for the results for carbon footprint, for example. We didn't extend the analysis to reporting ranges by state or by region, really due to confidentiality concerns from, the major processing companies. So we do a bit of sensitivity on there, which does give some insight into how those ranges might vary. The state electricity grid is a big one there. And I think if we compared Australia's highest emission intensity energy grid, Victoria with all its brown coal, with Tasmania, which is predominantly renewables, the difference in carbon footprint was around 0.4 of a kilo, so higher in Victoria to lower in Tasmania, which is the status quo. However, if those reductions in or increased renewables in all the state electricity grids continue, and there's no other change elsewhere, we should see those emission intensities decrease over time.
Thanks for that, Fran. The next question here, I think you might have already answered that a little bit already, Eugene, just in regards to quantifying the emissions from chicken litter. Are you able to do that?
Yeah, I suspect it's broken down in that report, won't it be, Fran, exactly what the emissions are for each part of the whole supply chain, right through for the feed grain production to, the upstream breeding and hatchery stuff to the on-farm stuff, which then splits your manure emissions and even your purchase of litter and stuff in there. So that should give you a breakdown. But as I said, they are quite low. Like, that's the advantage of the chicken meat industry has, I suppose, is that you are a very low emitter. And part of the reason is that, they're not like pigs that are producing lots of methane in ponds, or they're not cattle and sheep that are going around burping everywhere producing lots of methane. So it creates a very low emission product, which I suppose then brings the challenge, like, how do you actually bring it down when you're already pretty low, and you're going to be, and the target is then obviously looking at the things that, there's this study showed, what are the things that are the high emitters, i.e. soybean meal's driving that a lot. Yeah. But you can still do things with energy and stuff on farm, like energy efficient things, any of them. But remember that benefit from the energy, if you believe that the grids are going to be decarbonised, and it's the same with putting solar on, your benefit of doing that is reduced, because it's going to happen. If you believe that it's going to happen, that we're going to, decarbonize the grid. So you'd really want to be looking at things from solar from a cost benefit point of view in the future, 10 years down the track, because presumably the electricity you buy will have a lower carbon footprint in it, just as they decarbonise the grid. So you want to look at it from a cost point of view, because if they do that, grid electricity has to get higher, and things like LPG will get higher.
Yeah, this question really does follow on from that too, Eugene. It's really about the broiler farm and how can they actually reduce carbon emissions. What recommendations have actually come out of this study? And, is it really just solar panels that can be used to help reduce? And as I said, that does follow on.
There's not, as I said, there's not a lot you do with the manure, because the manure emissions are quite low. But anything to do around energy efficiency as it is now, like particularly, say you're in a state like, as Fran pointed out, if you're in Victoria, you have when she talked about a 0.4 number, it is actually a big deal from an electricity point of view at the moment. Like the difference between Tasmania and Victoria, the intensity of the grid is like, 8 or 9 or 10 times higher. So for every kilowatt hour, it's, in Victoria, it has that much more carbon footprint with it. So on the farmers, that stuff. But sort of watch this space a bit, because I think new technologies will start to come up. I think I asked you one about the other day, Rochelle, the ground source heat pumps as an option to offset LPG. I was trying to actually, Byron's probably on the line here, I was trying to get hold of him, but I have actually tracked down one. There is a project running with that, for that arena of funded, I see, in south of Sydney at the moment, to basically offset LPG use on the farm. So these technologies will start to happen, and they'll become more cost effective, I think. Obviously, as you've seen the interest grow in this area in the last year or two.
Yeah, absolutely. Thanks, Eugene.
But other things, like little things like feed conversion, obviously, because feed's driving this thing a lot. You'll see that, the chicken meat industry has been very good at driving down feed conversion ratios, and that makes a big deal. But that's obviously, you don't have any control over that as a grower.
No, fair enough. This question is actually in regards to the genetic improvement in feed conversion. So, does the industry projection of the 2% growth in emissions a year take into account the genetic improvement on feed conversion and the increasing economies of scale of increasing sheds and farm sizes? Has that been taken into consideration in that growth?
Yeah, so we definitely took into account, I think, the trend or average, trend reduction over the past actually more than a decade, I think, of 0.02 per year in feed conversion across the industry into those pathways. In terms of economies of scale on farm, not really. That is something that's definitely worth looking at. And I guess it is something that, it's really a watch the space again, in terms of we are in a project at the moment to sort of do a smaller version of this project in terms of benchmarking and determining impacts, particularly carbon, for the industry on an ongoing basis. So hopefully over time we should pick up some more of those changes in production system, and who knows, potentially revise those pathways and projections in the next few years.
There's probably another point that didn't come out that Fran mentioned, because she was talking about intensities, the kilos of CO2 per kilo of chicken, you produce, but then there's a total industry emission. So I suppose one of the challenges for industry is because you're a growth industry, this, setting targets to reduce it becomes a bit of a challenge for you as people eat more chicken meat. Like, as people eat less red meat, like, they actually get an overall emission reduction just because less of it's running around. We see those big impacts with the sheep industry have happened, like how a lot of the sheep industry disappeared over 20 to 30 years. So that is a bit of a challenge, obviously, that whole thing, how you reduce your total emissions when you've actually got an industry that's actually growing.
Thanks, Eugene. We've still got some questions to get through. I'm just a little bit mindful of the time, but anything that we don't get to today, Fran and Eugene have kindly offered to answer them outside of this session. So hopefully we can get all of the questions answered at some point. But the graph that you had showed an emissions reduction based off soy being removed from broiler diets. Was a trial done such as was a trial done, and if so, what was the outcome, the feed conversion?
Yeah, no, good question. So it was a high level sort of desktop analysis in terms of if we reduce it or remove a significant portion of protein and we need to put it back in terms of other proteins or increase amino acids. Really one of the follow-ons out of this project is that there is a study going on at the moment, which we're involved with, which is around modelling the impact of those lower emission intensity diets, but also engaging with the nutritionist to make sure that that does extend to actually ensuring that we don't have adverse impacts on bird performance or FCR. Unfortunately, the project didn't extend to a full commercial trial. However, I think, yeah, there are a number of researchers, I think UNE and UQ in particular at the moment, who are sort of involved in trials to reduce soybean meal in broiler feed. Not necessarily, not at this point in time, a collaboration and also reduce environmental impacts across multiple indicators.
Thanks, Fran. Given the fact that soy alternatives play such a big role, any idea on what some practical alternatives could be? There was some questions also around, alternative feed sources like insects, potentially other types of cotton seeds, maybe, or even other sort of waste from other crops as well. What are some of those alternatives?
Yeah, so things like faba beans, field peas, cottonseed meal, canola meal, all viable. Probably the only thing about cottonseed meal, because we did run a bit of analysis on this, is that one of the trade-offs there might be that you actually increase the water footprint of the feed and of chicken meat production, because that's a byproduct of a system with such high levels of irrigation. In terms of those more novel proteins such as insect meal, black soldier fly meal, I think the researcher at UNE or UQ has also been looking at pondweed and that sort of thing. They do seem to be viable. It's just availability is one of the things which is key, that currently there are either such small volumes or it's not a consistently available product, that it's hard to sort of, consistently incorporate into a diet the way that soybean meal is really always available.
Yeah, and Fran made a good point there about that burden shifting thing, because a simple thing is, we go to US soybean, which was when we did the study 10 years ago, but then remember a lot of that's probably grown on irrigated land, so then you have this massive increase in your water footprint. So that's the advantage of using LCA, because you're looking at a number of sustainability indicators. You're not just interested in what your GHG emissions are.
Thanks, Eugene. I might just do one more question, and I know that we're not going to get through all of them, so my apologies, but what we will try and do is see if we can get these questions answered, and if I could send them out with the links as well. So I'll just do one more. Is hydrogen as an alternative energy source being considered?
That's a question for the engineer, Eugene.
We certainly hadn't included it in this study, but yeah, it could be part of the mix. Yeah. So we've even had a bit of a look at some individual companies. We've done a bit of work around even with methane, and then combusting methane, capturing the methane, combusting the methane, so then it emits CO2, then actually getting what you call green CO2, if you know what I mean. So harvesting that at a piggery or a poultry farm, so basically getting the CO2 emissions that come off the generator, and because they're biogenic ones, because they come from a feed essentially through manure to them, and then basically having green CO2 as a saleable product. So there are a few things, a few other options and stuff there. And I suspect, we're going to hear more and more about hydrogen, because there's a lot of investment happening in it. Yeah, they've put a lot of eggs in that basket, governments have.
Thanks for that, Eugene. I really do appreciate the time that both you and Fran have taken this morning. Fran, for that great presentation, Eugene, for your wonderful knowledge and being able to answer some of these wonderful questions that we've had. Unfortunately, we haven't been able to get through all of the questions, but as I said, we will try and endeavour to have them answered. Thank you again. Wonderful presentation. Great finish to our webinar series for this year. Thanks, guys. And we do have a quick survey at the end, as always. Hopefully it works. But thanks so much for your time, and Merry Christmas, Happy New Year, and we'll see you all again next year. Thanks, Eugene. Thanks, Fran.
Thanks very much, Raquel.
Thanks.